The James Webb telescope just captured something mysterious beyond our solar system. The new James Webb Space Telescope has provided us with some stunning evidence of just how big the universe really is. The telescope has spotted a gigantic object 100 times the size of the Milky Way galaxy. This massive object is so big that it challenges our current understanding of the cosmos. The implications of this discovery are huge. It means that the universe is even bigger than we thought and that there is a lot of hidden mass out there. This has major implications for our understanding of the universe and its evolution. With the introduction of powerful new telescopes, like the James Webb Space Telescope, we are poised to make even more discoveries about the universe we live in. The James Webb Space Telescope is the most powerful telescope ever built, and it will allow us to see further into space than ever before. Its development cost of $10 billion are a testament to the importance of this project, and the immense complexity of the telescope's design. The history of our universe is one of never-ending expansion. From the Big Bang to the present day, the universe has been growing bigger and bigger, and as it grows, so do the objects within it. The Alcyonius galaxy is one of the biggest objects in the universe. It was discovered accidentally by scientists who were studying a different galaxy. When they looked at the data they had collected, they realized that there was another galaxy behind the one they were originally studying. The Alcyonius galaxy is so big that it takes up more space than our own Milky Way galaxy. It is also one of the most luminous galaxies ever discovered. Scientists believe that it is home to billions of stars and possibly even more planets. Alcyonius classifies as a radio galaxy. A radio galaxy is characterized by a supermassive black hole in its center. This black hole pulls in the surrounding matter and subsequently emits energy through two radio jets originating from opposite sides of the galaxy. These jets are referred to as active galactic nuclei. Radio galaxies are not common objects. They are mostly found in areas of low density. They have a total linear length of at least 2.3 million light-years. Astronomers study radio galaxies in order to expand their understanding of the origins and development of radio emissions. It is fitting that the name Alcyonius was borrowed from Greek mythology, as the name perfectly suits the research team's picked namesake. In Greek mythology, Alcyonius was the son of Ouranos, the primordial god of the sky. Alcyonius was a behemoth who fought Heracles and other gods for control of the cosmos. A sculpture of Alcyonius can be found at the highly renowned Pergamon altar located in Berlin. Given the gargantuan and titanic nature of Alcyonius, it is only befitting that this name was chosen for such an ambitious research project, with the potential to upend current ideas about the universe. The discovery of Alcyonius is a remarkable achievement that has shed new light on the developments of radio galaxies. This finding challenges several long-held theories and provides new insights into the behavior of these objects. The fact that this galaxy was photographed with two plasma plumes is particularly unusual, as it is not something that has been observed before. This finding suggests that there is more to learn about the sphere of influence of these galaxies and their effect on the development of radio galaxies. The size of the Alcyonius galaxy is still unknown, as scientists can only estimate the length of a galaxy from a single perspective, that of the Earth. However, the low estimate of the overall length of the Alcyonius galaxy is still incredibly remarkable, at 16 million light-years. This is comparable to aligning 100 Milky Way galaxies. Out of the 1,000 radio galaxies discovered by scientists, only 10 are longer than 10 million light-years. The second data obtained by the LOFAR 2-meter sky survey, or LOT, was used to discover Alcyonius. The reprocessing of the LOT-DR2 data has allowed for the investigation of a new sensitivity domain for radio galaxy lobes. The 60 and 90 resolution images have shown that there is potential for the discovery of new radio galaxies of vast angular length. The close proximity of Alcyonius to Earth makes it an exciting target for future study. This discovery is exciting for astronomers because it allows them to study some of the most difficult to define features of the universe. The cosmic web, which refers to the modern grown-up universe, is made up of a network of threads and nodes known as filaments and clusters. By studying the plumes of Alcyonius, scientists are able to learn more about these filaments and how they are structured. Because the medium between galaxies is so spread out, it has been difficult for scientists to detect. Alcyonius, however, occupies a filament. As its plumes travel through the medium, they experience a headwind. This also happens in the case of the Milky Way. But what is noteworthy is that this gentle headwind modifies the direction and shape of the plumes. By studying Alcyonius, we may be able to gain a better understanding of the medium between galaxies and how it affects the shapes of galaxies. Scientists have long thought that the shapes and pressures of radio galaxies' plumes could be negatively impacted by the properties of the surrounding filamentary gas. However, the discovery of the Alcyone systems reveal that the plumes in this system are so large and rare that the surrounding medium can relatively easily mold them. When researchers first found Alcyone, they believe it was produced by a gigantic black hole. However, further study has shown that this is not the case. Alcyone does not stand out in any of the three features that would indicate it was created by a black hole. So what is the origin of Alcyone? The fact is that we don't know for sure. It is possible that it is a natural formation, but it is also possible that it is the product of some unknown process. The origin of Alcyone remains a mystery for the time being. As is widely known, planets have moons. Earth, for example, has one, a fact that any high school geography student can attest to. Some planets such as Jupiter and Neptune have numerous moons. However, it is less common to find asteroids with moons. Out of the approximately 1.1 million asteroids discovered so far, only 150 have moons as companions. But astronomers have found an even rarer asteroid that has 3 moons. Electra, an asteroid in our solar system, has 3 moons. This is unusual because most asteroids only have 1 moon. How did Electra acquire 3 moons? It is essential to point out that while Electra was first considered an asteroid in the 19th century, its title as the supreme commander of an army of 3 moons was only recently confirmed. The asteroid belt, located between Mars and Jupiter, is where the 160-mile-long asteroid was founded in 1873. Its first moon was not discovered until 2003, and its second moon was discovered in 2014. Electra, also known as 130 Electra, showed researchers how to detect other weak and elusive moons, such as those attached to asteroids. Since asteroids are rather small and only weakly illuminated, anything even smaller put adjacent to one will be fainter and darker, since it will most likely be outshone by its parent asteroids, making it more difficult to see moons that are smaller or closer to their parents. The first moon is approximately 6 kilometers long, and on average orbits Electra at a distance of 1,300 kilometers. The second moon is even smaller, measuring a little over 2 kilometers across, and on average orbits the asteroid at a distance of 500 kilometers. The newest moon is also the smallest of the group, measuring 1.6 kilometers in length and orbiting at a distance of around 340 kilometers. But it is difficult to see because it is 15,000 times fainter than the asteroid. The third moon of Electra was discovered by Anthony Bordeaux and his colleagues at the National Astronomical Research Institute of Thailand. They processed data from the Sphere instrument mounted to the European Southern Observatory's Very Large Telescope through a data reduction pipeline to reduce noise from the raw data. The Sphere captures extremely detailed images of objects in space, and with the aid of a 10-meter telescope, it can extract images of extremely dim objects. The third moon was detected in older images using modern processing techniques. These methods were used to predict and erase the asteroid's wide light, known as a halo. Even though it was discovered after data had been processed, Electra's third moon had always been there. It was hidden from the processing tools that were available in 2005. Researchers are still trying to understand Electra and her moons in various ways. They don't know how the 4 items became connected. One theory is the creation of the 2-moon asteroid Cleopatra. Scientists were able to work out that the twin moons probably formed a material that was ejected from the parent planet, even though they hadn't yet figured out how often the process occurs in the solar system. It's possible that all 3 moons were created in a similar manner to the Earth's moon. Precision and mass estimations is one reason why researchers search for asteroidal moons. The size and composition of an asteroid can be used to estimate its mass in the absence of a moon, but this method may not be accurate. However, if there is a moon present, astronomers can use a set of Kepler's equations to calculate the mass of an asteroid. By extrapolating an asteroid's density from its mass and size, scientists can learn about its composition. This can tell whether an asteroid has metals inside or is just a collection of low-density pebbles held together by gravity. As a result, the only way to learn a lot about an asteroid is by learning about its moons. Also, remember that the moon was discovered by analyzing existing data from a new perspective. Consequently, there may be several moons still concealed in old data, just waiting to be discovered. It simply requires someone to take another look at the data. Consequently, the finding of Electra is only the start. There will be more discoveries in the future. Now, let us know what you think about these incredible space discoveries in the comments section below.